Okay, so today I'm going to be reviewing for your test that you have actually this week. Uh, I am not going to be showing my face for most of the video. So what I'm going to be doing is I'm going to go from your review, chapter 10 review, which is on page 483, which is what your test is going to be. So I'm going to be working the odds because obviously they're in the back of the book. I have found a mistake in the back of the book. It is on number 9. So as I'm working it, I'm going to show you what's wrong with it and what they did incorrectly. It's kind of obvious once you figure it out, but I don't know whether it'd be obvious until you see what they did. All right, so I'm going to flip my camera around and I will be working every odd except for the back where you are going to be graphing on 36 through 40 on the evens. You are just using Desmos or your calculator to graph that. I want the Y and the X axis labeled. So as in with radians, if you do it in radians, if you do it in degrees, please show me that and show me specifics. So I'm not going to do that for you because I think all of y'all understand how to do that with the graphing calculator. If you don't, then shoot me a text and ask me for help and I'll work something like it and put that on YouTube. All right, here we go. Okay, so I'm going to start on the first one. All right. We're kind of backwards. Let's see if I can flip something around. Never had this happen before, but I guess it doesn't really matter. I guess it probably happens every time. And I just don't even notice that it's flipped. Okay, so on my side of the paper, no, we're all good. Forget what I just said. It's early. I've been up since 5, didn't sleep very much last night, thinking about all of my videos that I have to be having on YouTube by 10 a.m. So, my own fault, but I'd rather have the weekend off, and that's what I did. Okay, so on number 1, what you're given is a triangle that looks like this, and it won't be perfectly clear. Let me see if I can come down better for you. We're trying. Okay, we'll go with this. All right, so it's asking you to find the 3 basic trig ratios for each acute angle. All right, trig ratios, the 3 ones are sine, cosine, and tangent. All right, so you have 2 of the sides that you know, and in order to figure out this side over here, we're going to be using the Pythagorean theorem. So we have 2 squared plus 6 squared equals, we'll call it little c, okay, because it's across from the C angle. And you'll notice when they measure, sorry, in the book, I think it does this. In the book, when it's talking about the angle, it's going to be a capital. If it's talking about the side, it's going to be the lowercase opposite that angle. All right, just so that you follow along. So this is 4 plus 36 equals C. Okay, and then we have, I'm going to flip it around. C is equal to 40. Okay, and whenever you're doing this, we are going to, sorry, I missed something. Just a moment. Okay, those should be 2's. So this should be this, and then we square root it, square root it. C is equal to, now you're going to have to break this down. This is the problem with this. All right. So we have this like here, and 4 is a perfect square. So we're going to pull that answer out because this is basically square root of 4 times 10. Whoops, square root of 10. Okay, like that. So what is the square root of 4? Yep, it's 2 square root of 10. Okay, so we have now solved for this side right here. I'm going to write it so that I can see it. Okay, so that was just kind of half our battle because what we are looking for now is the sine, cosine, and tangent. Okay, now it says we're looking for the 3 basic trig ratios. So you might go, well, what's our theta? Okay, you're never going to do your theta as C. Okay, you're either going to pick A or B. Sorry, it's kind of hard to do. We're trying to look and do the camera at the same time. I don't know if you see this in the shadows. That is my camera, is the document reader that I had in the classroom. So it's not the perfect scenario, and that's why it's slightly blurry, because it's probably 1980s technology. Maybe not, but you know what I mean. It's old. All right, so we have sine theta. What I was trying to say before is, let's say, for instance, we said theta was A. Okay, when theta is A, the sine of A is going to be the same as cosine of B. Okay, and so we're really not going to have to solve for that, because we're just going to say that it's equal to. Now, just keep in mind, you do have to think through that to figure out which one is which. Okay, and then this one, the tangent, we actually have to solve for the tangent of B. So scratch that. We'll go ahead and solve for tangent of B in the end. Okay, so we'll come back to that. So our theta is going to be A. So up here, in here, we know this is what I do every time I'm dealing with trig. Okay, I know some people don't like this, but I love SOHCAHTOA. It helps me remember everything. Okay, even at my age, this is still what I'm going to use. I learned this at your age, but I still use it because it's a perfect acronym for this. All right, so we're going to go for sine of A, and sine of A is opposite of A, so that is opposite A is 2. Okay, and it's over the hypotenuse, which is 2 times the square root of 10. Now, one thing that you have to remember is you cannot leave a radical in the denominator. Remember, no math person likes that. Well, you might be like, what? I like it. Anyways, so you're going to rationalize the denominator, that's what we call it, to get rid of the radical sign. I call it, for my younger classes, pop off the radical bar. All right, so the radical of 10 times the radical of 10 would be the radical of 100. And what is the square root of 100? Well, it's 10. So down here, we would have 2 times 10, which would end up being 20. Okay, so this is equal to 20 on the bottom. And then on the top, it would be 2 times the square root of 10. And if I had more room, which I don't, I would show it prettier. But the sine of A is the square root of 10 over 10. You cannot reduce it any farther. And that is also the cosine of B. All right, so then we're going to come over to do the cosine of A. So I come back over here. Cosine of A is the adjacent over the hypotenuse. Adjacent is right next to. Okay, so we're going to have 6 on top. And on bottom, we're going to have that 2 times the square root of 10. Okay, now I'm going to do something different this time. You might have seen it before, but you know, what am I going to do if I don't have Andrew right in front of me to see these things? Or Emily. Okay, I'm hoping you hear your names. So we have this, and we have this, and that's fine, but we still need to rationalize that denominator. So we have here and here. So we have this 3 times the square root of 10 on top, all over 10. All right, and that is going to be equal to your sine B as well as your cosine A. All right, so that's what I end up with. And again, when you're doing this, I want work to be shown. Please don't put this into your calculator and give me a decimal. Okay? No decimals, please. Please leave it in this form. It's easier for one, for me to grade, two, for me to see your work. Otherwise, I'm just going to think that you can punch calculator buttons and that's your talent. And that's not what I'm going for. Okay? All right. And you will notice this whole test is not as hard as this unit has been, but because we're doing distance learning, there's only so much that I'm going to require. And this is the basics of trig functions that you will need to know. You will use trig functions again in pre-cal if you ended up taking that next year. That's taught by Mrs. Kamak, and it is a great class if you're going to go on in math. If you're not going to go on in math, you might be ending up taking business math, which you might see my face, because who knows what I'll be teaching, but that is always an option for me to teach business math. So I may have some of you again next year, maybe not, because they always keep us on our toes. So back to tangent. All right, tangent right here is opposite over adjacent. Now remember, we're dealing with A, so tangent is opposite of A over adjacent, and this makes it a whole lot easier, and that is just 2 over 6, which I'm going to actually just reduce to 1 over 3. All right, now you will know that the tangent of B is the opposite. Okay, so I'm going to come up here. Tangent of B would be the opposite over this. So I said opposite. Okay, it is opposite. It's an inverse fraction, but I'm not using the word opposite the way that they should be over here, but it's still, B is opposite 6. So that's good. But what I'm saying is we have the reciprocal of this when I'm really saying it's the opposite. Okay, so the tangent of B is 3. So that was number 1. You're going to do that for number 2. You're going to find sine A, cosine A, tangent A, and they are going to be the flipped version of these. Now on 2, it's not going to be A and B, it's going to be D and E. All right, and don't forget, do not leave a radical in your denominator. If you do, you will probably lose half points, depending on what your work is. All right, so that was 1. We're going to go to number 3. All right, so number 3, it says state the 6 trig ratios for each acute angle. Now, I will tell you, this is super duper easy because you're going to be using your calculator. Okay, I'm not sure. I'm trying to show. Okay, here's my phone. All right, which it's showing a lot of fingerprints. Okay, so ignore this number. So if we are doing number 3, this is number 3. One thing that you need to remember is you can know what this angle is by 90 plus 43 is 133 degrees, and then we take 180 minus 133 and we get 47 degrees. So this right here, I'll move my hand in a moment, is 47 degrees. Okay, and that's everything that you would need to know. All right, so on this, let's say for instance it's asking us for all the 6 trig ratios for each angle. Now remember, kind of like what you did, I believe, on a homework assignment, if you have sine M, that's going to be the same as cosine K. Okay, so you don't actually have to do 6 different amounts, but if we're doing sine M, you are going to, depending on how your calculator works, but for mine in particular, you put the degree in, and then I'm going to find my sine button, which I know you can't really see that very clearly. Yeah, not clear at all. Okay, so this is sine, and you would get this 0.681, and it goes on forever. But one of the things that they do, they haven't even given you round to the nearest on this particular one. So what they've done in the back of the book, and I would say do this for number 4, is you are going to go to the nearest tenths, hundredths, thousandths, 10,000ths. Okay, so that would be on this particular one, 0.6820. Okay, if you want to do a different decimal, just tell me what you did. So if you're going to round to the nearest tenth, please put it, denote it on your paper, nearest tenth, like write it over here. If you're going to do something like this and you want to change up what you're doing, be very specific and then tell me like 0.7. Okay, if you put 0.7 and you haven't told me, and it's not to the 4 decimal places, I will take off a point for not being as exact as what the book has said. Okay, if you forget when you're taking the test, always look back at number 3 in the back of the book to remind you what the decimal will be. Okay, now you are going to keep going. This is just a calculator function, so I'm not going to go ahead and do it all, but I'm going to show you using angle M what all the 6 functions are, just so that you can remember and have it in your brain. Now, just in case you wonder, this is an open book test, okay? I'd prefer if you did not use your notes, all right? So don't just have this review out in front of you, okay? You can do this open book, but not open notes, okay? So you're going to go through and do all of this right here in your calculator, and you're going to find that it's equal to, if you had M, you've got sine K, you've got, this is the opposite of that would be cotangent K, the opposite of this one, secant K, the opposite of this one, cosecant K, and tangent K. You can always go back and figure out in your brain what's the opposite of it, or you can do all the hard work and do 12 functions, up to you. But I'd prefer, if you didn't have to do it, you don't have to do it. So that was number 3. Okay. All right, number 5, we are dealing with this. Okay, so I've already solved for some of this because I had to do some of the work beforehand so that this video wouldn't be super long. One of the things wonderful about my mic, okay, wonderful about teaching in a real life classroom is I can just teach as I go, and it's not like a stumbling process. But when you're having to write it down, this is what happens. Okay, so what they've given us on number 5 is the sine of theta. All right, and they have not drawn any triangle for you, so you know it's a right triangle because that's what we're dealing with. Okay, so I just picked an angle. So I drew a triangle. I would suggest you do that so you can get that, your brain wrapped around it. And then in order to solve this side, we're going to use the Pythagorean theorem. Now, I went ahead and did this in my brain. I told you I always use that. This is opposite over hypotenuse, and they've already told us opposite over hypotenuse. And that's where I got opposite of theta is 20 and hypotenuse is 29. Hypotenuse is always across from the right triangle, or right angle, sorry, not the right triangle. 29 squared, that hypotenuse right there, is equal to 20 squared plus x squared. I labeled this as my x. It's my only missing side. And so I went ahead and did this. All right. So I got 29 squared, 841, 20 squared, 400. I pulled this over, which I subtracted, and then I flipped things around. So I want my x squared on my left side just because it's pretty. All right, so x squared is equal to 441 square root of 441 happens to be 21, and everything is beautiful there. All right, so we know at that point that our x is 21. Now it says state the other 5 trig ratios for the acute angle theta. Okay, so what I've done here, right here, here's our, let's see if I can do this so you can see this, all of this. Okay. All right. So I go ahead. I know I've already got this one. Okay. So my cosecant right here is the opposite of that. Sorry, flipped of that. Okay. So you're doing the reciprocal of that. So I have the cosine, sorry, not cosecant, cosine of theta is the adjacent over the hypotenuse. And I didn't go ahead and do all of these so that you can kind of watch me. We have the adjacent to theta, which is going to be our 21 over our 29. So this is 21 over 29. And this is also our secant of theta because it's flipped. All right. Now over here, I have tangent theta. Tangent theta is TOA, right? Okay. So opposite of theta over adjacent of theta. So that would be 20 over 21. Okay. And that's also equal to my cotangent of theta. All right. Hopefully that made sense. And we went through those 5 other functions. See, 1, 2, 3, 4, 5. Okay. That 6th one was given to us. That was the sine theta. All right. Number 7. Okay. So they have given us this triangle right here. We have 16 degrees. We also have 8. Okay. And like I said earlier, their y, you see their angle y, the lowercase is across from it. And this is z. This is our 90 degrees. And across from it is the letter lowercase z. Okay. So we're going to solve for all that we can before we do anything. And then we will go ahead and do what the problem asks. Okay. So I have 90. Because of my 90 plus my 16 gives me 106. Then I have 180 minus 106. I got 74 degrees. That is my angle y. Okay. Now it says in the directions solve each right triangle, round lengths to the nearest tenth, and angle measures to the nearest tenth of a degree. Okay. So this one, I don't have to round because it's a whole degree. So I've got that. Then all I'm missing are these sides. Okay, so I need to, because when it says solve for the triangle, you want all sides and all angles. So we already had that angle. We have this angle. We've now got 74. And now we're going to solve for the letter Z. So I chose to do 16 degrees. So the sine of 16, which remember, sine is opposite, which is 8, over hypotenuse, which was z. So that put the z on the bottom. Okay. And then when I go ahead and do my algebra, okay, all I did was bring it down. Okay, so my z's canceled, my sine 16's canceled, and I now have z is equal to 8 over sine 16. Now, sine 16, you're going to have to put into your calculator. It's ridiculously long because they're going to be ridiculously long. Okay, so I put that in, and then on my calculator, let's see if I can show you. There's a button on my calculator. Let's see if you can see it. It's right over here. I don't know, not that one. Okay, we don't need that one. This is 1 over x. So like, let's say I used 5 and I wanted the 1 over x, it would be 0.2. It's a handy dandy thing. So if I had 16 and I hit sign, that's my sign 16. And I want to put it in 1 over because it's on the bottom. Okay, and so I did that, and then I times it by 8, multiplied it by 8, and I get this fabulously long number, which is right here. Okay, but pay attention. It says round the lengths to the nearest tenth. So we rounded to 29.0. But remember this, when you have this one rounded, don't use your rounded formation in your other formula. Okay, sorry, I pointed up here and I didn't want you to get confused and use the rounded. So let's say the sine of 74. So sine of, remember this is 74, sine is opposite, so that's y over hypotenuse, which is x. Okay, we could have done, let's see, the tangent of y, because we already have 74 and we have y and we have 8. That's fine. You could do that. You will get the same answer. Okay, but I happen to use sine of 74 equals y. I went back to my z, this one, not my 29, but this form. Okay, the long decimal. And I put that 1 over, and I didn't put it as 1 over, sorry, because whenever I'm solving for y, I could bring that z over here. So I didn't do 1 over. I did that 29.0236 blah, 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 times sine of 74. Again, the Andrews of this world probably would be smart and use this 8 instead of that fabulous decimal. Either way, you get the same answer. So my answer in the end for y is equal to 27.899, and it went on forever. And then I rounded to the nearest 10. Okay, and so I have now, I have this, and I have this. Okay, so I've now solved for the entire triangle that I needed. Okay, all right, the last problem that I'm going to be working for you. Okay, so number 9, they give us this triangle. Okay, now first of all, I want you to feel available to use this. This is an open book test, but not an open notes. Okay, so this is page 439. That's the one that has the special right triangles like this. Okay, it also has the one that you will need for number 10, because I do realize number 10 is a 45, 45, 90-degree angle. And so it's going to be different than this one. All right. So what they did in the book, they switched things around. Okay. So really quickly explaining what they did incorrectly. Okay. Incorrectly, what they did is, because if you look at the answers, it went ahead and said angle A was 30. Well, I don't know how they got that, because in the book it is clearly labeled angle A, at least in my book. If it's not labeled like this in your book, if it's fixed in your book, please tell me. But in my book, let's see if you can see it. Nope, can't see it. So let's go back to the clearer, blurry version. Angle A was 60. Okay, well, the way that they answered it, it had to have been up here. Okay, and so they ended up with something like this, which is what the back of the book is going to give you the answers on. But I'm going to work as if they made no mistake. Okay, this is angle A. Because this is A and this is 90, this is 30, and they told us 9. And I go ahead and write the basic formula. Now, what the basic formula is I kind of left this off. Not kind of, I did. This is a ratio, okay? The side across from 30 is not 1. It's a form of 1. Okay, so, and I say it's a form of 1. It's a multiple of 1. Let's just say that. Okay, so in this case, the form, if 1 is 9, okay, then the hypotenuse, this one right here, is 18. And then the opposite of 60 across this is right here. So the square root of 3 times 9 gives you 9 times the square root of 3. Okay, and on this, we have solved everything. Again, it says solve each special triangle. So in the book, you have solved for angle C. Okay, so that's part 1. Okay, and then part 2 is the hypotenuse. You found that. Okay, and then the opposite of 60, you found that. So I'm going to fill in so that you can see. Okay, do you see all of the parts are filled in? And that's the only thing that you need to do when you're solving a special right triangle. You need to have all 3 angles. Okay, and how we got that was 90 plus 60 is 150. We know angles add to 180. We subtracted 150 from 180 and got 30. All right, plus we already have it memorized, hopefully. So that is your review. I'm going to go ahead and put it up on the YouTube channel so you can get started. Again, please put your test in the folder, for Friday's folder. I'm pretty sure I put that in. Let me look and see in your thing. Yes, I said on the bottom, please turn this in via your Friday folder. I would like to grade the hard copy. It's just easier all around. So hope you're doing fantastic. The next 2 weeks, I can't promise what we're going to be doing, but this is your only grade for this week is the test. So we won't have another test. Okay, I can assure you of that, but we will have a few more grades. I'm going to try and wrap up this year with the important things. I do feel like we have covered well. Y'all have done super. Okay, I guess I could flip this around so you can see my face. All right, I am so very, very proud of you. I have less missing grades from your class than I have. Boy, that's a very large face, right? Okay, I've met less missing grades from y'all. Very, very pleased at how y'all got your stuff in. Even when I've had to email you, you've gotten it done. Thank you. Okay, so I do feel like you've finished the year well, and this is really great. One of the great things about having distance learning is it gives you an opportunity to pull that grade up. So those of you who are, wanting to make a higher GPA, good job. Okay, so I will just say the grades for y'all are the highest I think I've ever seen. So congratulations. I'm excited for you. And we just have 2 more weeks after your test for this class. And that is all. All right. Talk to you later. I love it when y'all send a note. So please feel free to send a note. People have been very creative in the younger classes. I've seen videos. So it's fun to see your faces. All right, later.